Objective, inequalities and their graphs. Definition number 1. An inequality is a statement that compares two expressions. Definition number 2. Solution of an inequality. This is any number that makes the inequality true. Less than or equal to, greater than or equal to. Notice on the two that are equal to, you have the bars underneath. Vic number 1, you can use a graph, a number line, to show all of the solutions since there is more than one. So when we solve an inequality, our answer could be 5 and anything bigger, or -2 and anything smaller. So we're going to use a number line to show that. A closed dot or a closed circle means less than or equal to or greater than or equal to. So the equal to ones are closed. If you have an open dot or an open circle, this means less than or greater than. It does not include whatever number is circled. Identifying solutions. Example number 1. Is each number a solution of x is less than or equal to 7? 9. So we're going to plug in 9 where x is. Is 9 less than or equal to 7? No, this is not true. So 9 is not a solution. -1. Plug in -1 where x was. -1 is less than or equal to 7. Well, -1 is actually less than or equal to 7. So this is true. So -1 is a solution. 21 over 3. 21 divided by 3 is 7. So is 7 less than or equal to 7? Well, yes. So this is true, and 21 over 3 is a solution. Is each number a solution of 2 minus 5x greater than 13? So here I have 3. Wherever the x is, you're going to substitute this number to see is it true or not. So I'm going to plug in 3 here, where the x was. 2 minus 5 times 3 is 15. Carry down the rest. Now 2 minus 15 is -13. Is -13 greater than 13? No. It's not true. So 3 is not a solution. -4. I'm going to substitute -4 where x was. -5 minus 4 times -4 is 20, greater than 13. 20 plus 2 is 22. Is 22 greater than 13? Yes. This makes it true. So -4 is a solution. Plug in -2 where x was. 2 minus -5 times -2 is 10, so 2 plus 10 is greater than 13. 2 plus 10 is 12. Is 12 greater than 13? No. This is not true. So -2 is not a solution. Graphing inequalities. Example number 3. Graph C is greater than -2. So because I have a greater than symbol, I know that when I graph this, I'm going to have an open circle because there's no equal to bar. So I'm going to have an open circle on -2. You're going to shade the numbers greater than -2 because this is a greater than symbol. So I graph a number line and I plot -2, and here you see an open circle, and everything bigger than -2 is shaded. Example number 4. Graph 4 is less than or equal to m. Now, usually we see the variable on the left side of the inequality, so you're going to want to rewrite it as m greater than or equal to 4. Now, these two are exactly the same. Notice that the open mouth is going to the m, and when you flip it around, the open mouth is still going to the m. So that's how you know you've done it correctly when you rewrite it. This equal to bar means I'm going to have a closed circle on 4. I'm going to shade numbers greater than 4 because it says m is greater than or equal to 4. Draw your number line. Here's 4, and shade everything greater than 4. Example number 5. 3 is greater than p. So we can rewrite this with a variable on the left side. So p has the open mouth facing away from it, is towards the 3. So again, when I rewrite it, it's still towards the 3. There is no equal to bar, so I know I'm going to have an open circle. And we're going to shade numbers less than 3 because this says P is less than 3. So here's 3, there's an open circle, and all of these numbers are less than 3. Writing an inequality from a graph. So here you're given the graph, and we can take these graphs and write the inequality statements. So you have an open circle at -4, and everything less than -4 has been shaded. So I used the variable x. You could use any variable that you want, a, b, c. I used x for these 4 problems. X is less than -4. Now I don't have the bar because I have an open circle. Example number 7. 5 has a closed circle, and everything bigger than or greater than 5 has been shaded. So closed circle means I'm going to have the bar underneath. Greater than, because the numbers bigger than 5 are shaded. Example number 8. Here, between 0 and -1, about halfway between 0 and -1, is -1/2. So I have shaded everything greater than -1/2. So I have a greater than symbol and -1/2 with an open circle, so no equal to bar there. Example number 9. 2 has a closed circle, and everything less than 2, so less than 2, and a closed circle means I need an equal to bar.